So Keith, we're here by the manifold, and I noticed that some of the pipes have actually got a kind of a black sheathing round rather than all being green. I mean, what makes these ones here different?
What we're trying to do is to make sure that we don't overheat in certain areas, and also that the flow from the manifold is insulated to the rooms that it's serving. So we've got a conduit which is given an air gap around the pipe, and that air gap, air being such a great insulator, just ensures that you don't get lots of hot spots where lots of pipes are together in one place.
So effectively, the sheathing, if you like, the conduit is there in the areas where you want to keep the heat in rather than actually let it out.
Yeah, exactly that.
Okay. Now the manifold itself, I mean, anyone who's got this sort of heating system will have seen one, and there's a pump attached and all that, but actually, how does it work?
You may have systems with heat pumps or maybe a condensing boiler. These run at different flow temperatures. So in this particular instance where it's working off of a boiler, we need to mix down the temperatures. So the flow temperature may be set to serve the domestic hot water, or could be radiators on first floors in some instances, not in this particular case. But what we can do is take this higher flow temperature, mix it with the return temperature coming from the underfloor heating, and these two mixings bring you down to the right temperature, which is probably somewhere between 38-40 degrees for this system.
So it's effectively a method of regulating the temperature in all of the different rooms at once?
It is. It's regulating the whole flow temperature through that manifold, but to a point that sits well with the type of conductive screed, the thermoplane screed, and also the floor finishes.
A lot of people might look at a piece of kit like that and think, have I got to drive that?
It's certainly a lot more complicated in the initial designs, the setting of balancing flow rates, pressure drops. So all the hard work is done in our office initially doing these designs. But in reality, once we've actually set the system up, it's been fully commissioned, really you don't have to touch it again.
So another really, really good example to self-builders and renovators as to why you've got to make sure that the person putting your system in really knows what they're doing in the first place.
Yeah, it's so important that not only to have a good quality product, but something which has been well designed, and actually the components have been chosen to make sure that you get the very best regulation. In this particular instance, we've got something which is quite new to the industry. It's quite normal to regulate the flows going through the different loops. We've got to make sure that the shorter loops have the same resistance as the longer loops, so that the water doesn't take its easiest path. But the problem has always been with flow gauges is once you set all this manifold up, it's very easy to lose that balance if somebody starts to fiddle around or you need to turn these loops off. This one in particular has got double regulating flow meters, and that basically means that once you've set it up, you've set the balance, all the flow rates are right, then if somebody goes to a later date and isolates that particular valve, once you come to open that valve, it will only open to its set point. So the whole manifold itself, once it's fully open, is only open to those set regulated points.